Ay, naka-record pa. Good morning, my name is Casey, and in this video, we are going to be talking about radical expressions and how to simplify them. If you want to learn how to add, subtract, multiply, and divide radical expressions, you can go ahead and check out my other classmates' videos somewhere in this channel. Alright, so radical expressions are algebraic expressions that involves roots. It doesn't have to be a square root, it could be a cube root, fourth root, fifth root, or sixth root. So over here, as you can see, we have the square root of 25. This over here, this sign here, is what we call our radical sign. And the variable or the number inside of the radical sign is what we call our radicand. So in this topic, we have what is called the product rule for radicals. If you have, for instance, the nth root of AB, then you can just write that as the nth root of A multiplied by the nth root of B. To explain this further, let's say that, for example, you have the square root of 2 times the square root of 3. You can just take 2 and 3, or A and B, under the same radical as long as they keep the same root. Now, for simplifying, you need to know the perfect squares. So that's 1, 4, 9, 16, 25, and any number that has a square root. So let's have the first example of simplifying. Here we have the square root of 75. Now, as we all know, 75 does not have a square root. This is why it is important that we know the perfect squares. Now, a perfect square that we can use is 25. 75 divided by 3 is 25, so we want to write that as the square root of 25 times the square root of 3. Just like that. Then you can get the square root of 25, which is 5. So your final answer should be 5 square root of 3. Another example here is with a negative 4 square root of 27. Now, since the negative 4 is outside the radical sign, it will be divided by the square root of 27. All we have to do now is to do the same steps as we did in the first example with the square root of 27, which is to find the perfect square that goes into 27. In this case, it's 9 times 3, which is equals to 27. Now we have negative 4 times the square root of 9 times the square root of 3. But then, you're also going to have to get the square root of 9, which is 3. So, we're going to end up with... So at this point, ignore what's in the radical. You need to multiply these two numbers, negative 4 times 3, and that will give you negative 12 square root of 3, which is your final answer. Alright, in this example, we have the square root of 16x raised to 4. We now have a variable and an exponent involved. The first step, following the product rule, we must separate the 16 and the x raised to 4. Then you can get the square root of 16, which is 4. As for this over here, we also need to get the square root of x raised to 4. And we're going to do that by dividing the exponent by 2. So that's 4 divided by 2, which gives us x squared. For our next example, let's say we have the square root of y raised to 5. So I really hope that you've understood all of this so far. But let's say you have the square root of y raised to 5. Now we have a problem because we cannot divide the exponent by 2 because 5 is not divisible by 2. So in this situation, we are going to have to find the largest number that is less than 5 but is also divisible by 2. So the only number that I can think of right now is 4, which is also divisible by 2. So now we can break it down to y to the 4th power times y. Now, following the steps, we need to get the square root of y raised to 4, which is y raised to 2 square root of y. And this is your final answer. So that's enough for the product rule. Now let's have the quotient rule. So in this rule, the square root of a over b can be separated into their own roots, which means that you can have the square root of a over the square root of b. So let's say you have the square root of x squared over 100. We can separate these two. So that will give us the square root of x squared over the square root of 100. So the square root of x squared is x, and the square root of 100 is 10. So that is basically your final answer. For example number 2, we have the square root of 2a raised to 6 b raised to 10 over 9. Now we know that we have to separate these two, but I'm going to go ahead and separate these 3 over here on the top just to make this a bit quicker. Alright, so we're going to solve for the variables first. The square root of a raised to 6 is a raised to 3, and the square root of b raised to 10 is b raised to 5. And this is when we put in our square root of 2 over here. And let's not forget the 9 at the bottom here. The square root of 9 is 3. So that is your final answer. For number 3, we have the square root of 5x raised to 7 y raised to 2 over 4. Let's go ahead and separate these two. So 7 here is not divisible by 2, so the biggest number that is less than 7 but is divisible by 2 is 6. So we're going to write that as now the variables with the exponents always comes first, so our final answer will be x raised to 6 y raised to 2 the square root of 5x over here over the square root of 4, which is 2. There's no more space. That's your final answer.